Evening, I'm Spot On Weather meteorologist Matthew Euler, and welcome to the latest video. This video is titled Good Things Come to Those Who Wait. And if you're a winter weather lover in the eastern US, sometimes you just have to wait a little bit longer than what you'd expect to wait. New York City is a prime example of this. Not getting any measurable snow yet to this point. But again, good things come to those who wait, and we still have some time left in the winter season to potentially get some wintry weather in the mid-Atlantic area. I know some parts of the Northeast have just recently experienced some winter weather, and they have potential to get a little bit more here coming up midweek this week. But sometimes, the atmosphere doesn't work according to our time schedule and what we hope for. So let's take a look and examine what's the latest information we have for today, the 23rd of January, 2023. All right, so my biggest considerations going forward from this point in time, the 23rd of January, for the remainder of the winter, these are what I'm really going to emphasize in today's video. Okay. First thing we're going to talk about is the state of the Madden-Julian oscillation, MJO. Could potentially play a very significant role in the overall weather pattern, and whether that MJO is a stronger or weaker magnitude MJO. That's very important to take a look at. We'll discuss that tonight. Additionally, we'll take a look at the latest stratospheric polar vortex forecast, looking at the various models. And, right now, everything is pretty much in consensus about a weakening polar vortex in the stratosphere. But then after it weakens, what happens next? And then finally, we'll delve into the teleconnections. And, we'll take a look at, for example, the Eastern Pacific Oscillation, the EPO, versus the PNA, Pacific North American pattern, with a battle over on the Pacific side. And then I also will get into some of the latest Ensemble model graphics, and we'll look at those and compare both the European as well as the GFS Ensemble. So first things first, tonight's video, I wanted to start off with just a general look at sudden stratospheric warming events of the past. And by the way, this graphic and the database in general of sudden stratospheric warming events goes from 1979 up to 2022, and this is maintained by Simon Lee. Just amazing graphics here, nice summaries, have the various dates here on each of these graphics to show about the stratospheric warming events. And generally what we're looking for here, in this case, is we're looking at mean sea level pressure anomalies with the reddish colors indicating above normal sea level pressure associated with high pressure, and then the blue coloring indicating below normal pressure. And generally what you have with sudden stratospheric warming events is you get a rapid rise in temperature in that second layer of the atmosphere, the stratosphere. And what happens is eventually that warming eventually results in an area of higher pressure over the polar areas. And then we get lower pressure over the mid-latitudes. And the lower pressure and the troughing is generally associated with colder temps in the mid-latitudes after sudden stratospheric warming events, while the higher pressure is associated with very mild conditions, dry conditions over the polar areas. So this is a great analysis by Simon Lee that was shared on social media. In general, what we're looking at on each of these particular thumbnails are the dates of the sudden stratospheric warming event, and then what was the North Atlantic oscillation? Was it positive or negative in these cases? What was the average out of all the sudden stratospheric warming events, the average North Atlantic oscillation, or NAO, at minus 0.39? And so what I did is I looked at these in detail. I went back and looked at the PRISM climate database and looked at the temperature anomalies for the month of March. What I was looking at here from the thumbnails, I was looking at just sudden stratospheric warming events for the month of February that occurred in February, which we very well could see that this February. And then what did the following March and even into April, what did it look like? All right, so what we determined from looking at this and analyzing the data, the first sudden stratospheric warming event that occurred in February, you notice all these are in February, but the first one happened in 1984, in late February, 24th. And what followed in March were much colder temps in the eastern U.S. The next one was 21 February 1989. We typically had near average temperatures in the eastern U.S. in the month of March, the following month, and then we had a colder April in '89. What about the sudden stratospheric warming event that occurred on 26 February 1999? We saw much colder temps once again across the east in March. And then we look back at 12 February 2001. We had much colder temps in the month of March in the east. The sudden stratospheric warming event from 18 February that occurred 18 February 2002. We had near normal temps along the east coast in March, and then we had the coldest temperatures back to the northwest over the northern plains after this sudden stratospheric warming event in 2002. And then the next one we examined out of all these on the left was 24 February of 2007, where we saw an actual warmer than normal situation across the east in March. So kind of against what you would normally expect after a sudden stratospheric warming event. We actually had warmer than normal temps in the east in March following that specific one in 2007. And then 22 February 2008, we saw near normal temperatures in the east in March. And then the 9th of February 2010. Now, 2010 was a unique situation. There are a lot of factors favoring very cold temperatures in the east. But in general, we just looked at the sudden stratospheric warming event alone, you would find that we had a very cold February. And then the coldest temperatures went for the deep south in March after the 9 February 2010 warming event in the stratosphere. And then finally, we analyzed the 12 February 2018 sudden stratospheric warming event, and we found that there were colder temps generally in March and going all the way into April. So it was a cold start to the spring in 2018. In fact, I can remember this particular year, in particular across Southeast Virginia, we ended up getting a little bit of a snowstorm in the month of March in the Hampton Roads, Virginia cities, which is very odd that late in the year. And that snow actually stuck and started accumulating to the roads and the ground, and it occurred after sunset in the evening. But in general, this is a nice breakdown. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We analyzed 9 total sudden stratospheric warming events in the month of February. And I was curious to see what the temperature anomalies were from that PRISM climate database the following month of March and even April in some cases. So in general, what we found is 4 out of the 9 sudden stratospheric warming events which occurred in the month of February, going back to 1984, 4 of the 9 actually featured colder than normal temps in the east in March. All right, so now, speaking of this, let's take a look at the present forecast for the stratospheric polar vortex. First, looking at the GFS model data from today, showing initially the timestamp here, the graphic on the left, the timestamp is 26 January. This is the forecast for this Thursday. We go here to the middle graphic, the forecast for 31 January, the end of the month. And then the far right graphic showing the stratospheric polar vortex forecast for 5 February. So what are we looking at here? What is of great interest on these graphics? First of all, the purple coloring, the green coloring that indicates below normal temperatures in the stratosphere, the lighter white coloring and this lighter salmon color in the middle of the white, as well as this maroonish or orangish color, that generally indicates above normal temperatures in the stratosphere. So we look, where is the coldest temperatures in the stratosphere occurring? And in general, we see 26 January, this Thursday, we see this stretched out or elongated shape across New England right on down to the mid-Atlantic. And so generally we have an elongated or stretched displaced vortex for this upcoming Thursday, the 26th of January. We see warming associated with these colors, stratospheric warming, generally at the higher latitudes there over the Arctic. Looking at 31 January, coming up after, this will be next week, right? We still see a stretched out or elongated displaced polar vortex over the North Atlantic, stretching down just over the open waters, the coldest temperatures, but we have the vortex generally stretched out still. We have a lot of warming going on across Canada in the stratosphere above Canada, also into Alaska. And then on the Siberian side, the Asian side, we see another warming that's taking place. This is warming number 2. So what you'll notice is we're seeing, based on these various dates, you're seeing various stratospheric warming events, not just one big one, but multiple ones. If we look here, the far right graphic, the GFS forecast in the stratosphere, for the polar vortex, still showing that weak vortex signature, generally over the North Atlantic to the southeast of Greenland. And we have yet another warming event occurring over the North Pole area. So we have, according to the GFS model, we have 3 distinct stratospheric warming events upcoming between 26 January, this Thursday, right on through 5 February. Now that's the GFS. Let's take a look at the GFS Ensemble forecast, which also shows a very similar situation for this Thursday, a stretched out or elongated shape of the polar vortex, generally going to result in some colder tropospheric temperatures over the eastern U.S. coming up late this week. We see that warming once again with the Jeffs model for this Thursday in a very similar location, very similar to the GFS. There's GFS on the far left for this Thursday. This is Jeffs. Very similar warming, very similar shape. And then the Jeffs by the 31st of January showing that elongation of the polar vortex out over the North Atlantic. We see a second warming situation now over the higher latitudes over the North Pole. And then on 5 February, we have complete warming going on. The warming's a little bit weaker, though, here on the north coast of Eurasia, the Jeffs model as compared to GFS. Let's go back to GFS. Look at the far right graphic here. Much, much greater warming on the GFS model as compared to the Jeffs model. Additionally, we see the very weak polar vortex signature here, situated generally over the North Atlantic just to the east of Greenland per the Jeffs model for the 5th of February. Now let's look at the European model for the stratospheric polar vortex forecast. 26 January, very similar, elongation or stretching of the vortex right on into the eastern U.S. We see a warming event occurring generally over the North Polar areas. And then 2 February, Groundhog Day, showing that polar vortex again have an elongated shape over the North Atlantic to the southeast of Greenland. And then we also see a secondary warming event. So no matter how we slice this, okay, all the models are showing the elongation. There's two main points I want to get across about the models for the polar vortex forecast. The first is the elongation or stretching of the vortex in all 3 models, GFS, Jeffs, and then on the far left here, this is European. All in great agreement. Great consensus, right? That gives us higher confidence that the shape of the vortex is going to be elongated, which is going to result in a period of colder temperatures in the eastern U.S. Additionally, on all these models, we're seeing some type of warming over the polar areas. Okay, whether we're talking GFS, Jeffs, or the European model, we see stratospheric warming occurring in all cases. So there's pretty good confidence now that there will be a stratospheric warming. In fact, there could be multiple stratospheric warmings, and I'm going to break that down shortly here after this slide. This slide, again, just a reminder of past shapes of the stratospheric polar vortex, which coincided with colder tropospheric temperatures. Colder temperatures here on the ground where we live. And this one occurred on the far left. This was back on 20 November. You see this purple coloring and the green coloring, and you see where the polar vortex was located. Generally, the tropospheric polar vortex was over Hudson Bay. 25 December, the very frigid Christmas period. Look at where the placement of that purple circular area is. Again, that's your tropospheric polar vortex reflection all the way down. A similar location, eastern Canada. And then finally, 14 January, just recently, we had a very stretched out look to the polar vortex in the stratosphere. It was another very cold day across the eastern U.S. this particular Saturday, the 14th. So again, I'm correlating shape with actual surface temperatures, and that's what I'm looking at here. Now, let's get back to the forecast for the polar vortex now. What we're examining here, this is courtesy of Z.D. Lawrence, okay? Graphic courtesy of Z.D. Lawrence. What we're looking at here, when we analyze for a weakening or a strengthening of the polar vortex in the stratosphere, we're looking at 10 hectopascal level, which is way, way far up above the ground, and we're looking at 60-degree north latitude for the zonal mean zonal wind. And what we're looking at right now today, right here, okay, we're seeing the winds, zonal winds, generally blowing at around 50 meters per second up here. But watch what happens over time with this wind. You see the wind scale over here and the vertical axis here on the left, ranging from 0 to 55 meters per second. See the drop off? This is the forecasted models, and look at the drop off. Very high confidence. We're having decelerating winds or slowing winds in the stratosphere, and basically by the 24th, let's see, that would be tomorrow, 24th, 25th. Our wind speeds in the stratosphere now have decreased to around 30 to 35 meters per second. And then as we go further out in time, by the time we get out towards 29 and 30 January, we see a significant drop off in those zonal mean winds. Those zonal mean zonal winds right here. Look at how we drop from about 50 meters per second today down to about 10 to 15 meters per second on average amongst all these different color lines. These are all the different models. But generally, we're looking at 10 to 15 meters per second where all the models are taking this. So we have a sharp drop off in the wind speeds in the stratosphere. That's what we're looking for a weakening polar vortex. We want weakening or decreasing wind speeds. We're getting it. Right? So all the models are in agreement. We are going to see those decelerating winds. And then the models kind of indicate that there will be a recovery of the polar vortex generally between the 30th of January and the 1st of February. See how these lines come back up again? So we have an actual recovery or a brief recovery of the vortex. Now the wind speeds increase again between 20 and 25 meters per second by this point, by the 1st of February. And then this tannish line here, this is your GFS model forecast. It's the most robust out of all of them, showing again a drop off of those zonal winds in the stratosphere down to about 15 meters per second. Now, if we wanted a major sudden stratospheric warming event, okay, we would want these winds to go all the way down below the zero line here. And it's not happening. The lowest point they're reaching is, again, between 10 and 15 meters per second, these zonal winds at 10 hectopascals at 60 degrees north latitude. So we do see a weakening situation of the stratospheric polar vortex. We see decreasing wind speeds, okay, but we don't see it to the point to where this dips all the way down to negative values, okay, where we're going to get a wind reversal. So bottom line is we are going to see warming events. Here on the bottom shows you the exact temperature rises here. This is where we're at today. So temperatures in Kelvin here on the left, on the y-axis. Generally today we're situated at about 212 Kelvin. That's our temperature today in the stratosphere at 10 hectopascals. Now watch what happens over time. All the models are showing this climb in the temperature. See this? So finally we get to a point right in this area here where we can see the temperatures increase from 210, 212 Kelvin up to about 230 to 235 Kelvin. So we are seeing some significant warming in the stratosphere by the end of this month, the last few days of January. And then we kind of see another spike by the GFS, another spike here in the temperature. The other models aren't thinking that way. They're kind of trending downward with the temperatures to more cooler levels again. But the GFS is the outlier with up to like 235, 236 Kelvin as we go into like about the 6th of February. Bottom line, here's the analysis of these charts. There's excellent model agreement that we're going to see a weakening stratospheric polar vortex due to this warming in the stratosphere. Now the GFS model is the most robust model, going to indicate the weakest zonal mean zonal winds down to just below 10 meters per second. The strengthening zonal mean zonal winds around 1 February. We talked about this right here, how they come back up again. Then a persistent values between 20 and 25 meters per second. So we're not nearly as high as we are today. We're up near 50 meters per second today. So we are going to have a significant drop off of those wind speeds. Now, the stratospheric warming at this point looks to be of the minor variety, not the major. And the minor events, by the way, can still result in displacement and that stretching of the polar vortex. And that still can impact weather across the mid latitudes, believe it or not. We don't necessarily need a major sudden stratospheric warming for some tropospheric impacts to be felt. Now, will there be, this is the golden question, the last bullet here, is will there be troposphere, stratosphere, troposphere coupling? In other words, will we see wave activity, this wave activity basically go from the troposphere up to the stratosphere and come back down to the troposphere? Or will this energy just go up to the stratosphere and we don't get the reflection back down to the surface? So this is really what we got to watch over time here, is if there'll be a coupling. We get warming in the upper stratosphere, we get higher pressure. Will we get some of that upward propagating energy to work its way back down towards the surface? All right, so that's the polar vortex situation. Now let's move into the Madden-Julian oscillation forecast, MJO forecast. Tonight in the video, I'm showing you the Jeffs V12 on the left, I'm showing the European model in the middle, and I'm showing the CFS V2 on the far right. All right, and all of these particular forecasts, well, actually the first two, the one on the left and the middle, go out to 6 February. The one on the far right, the CFS extended, goes out to 21 February. So where are we at right now as far as the Madden-Julian oscillation? We're seeing, we're basically situated, we've entered phase 3. According to the Jeffs V12 model here on the left, we're going to continue to, this is going to continue to amplify or increase in magnitude, the MJO, all the way down to 25 to 29 January is where we're going to reach our peak magnitude in phase 3, according to Jeffs V12, with overall rotation then getting weaker or less in magnitude as it rotates towards phase 4. European model, not so. European model taking it into phase 3, very similar there. But look, it's not as strong, the magnitude on the European forecast. And then by the end of January, the MJO rotates back into the small inner circle, the center of the diagram, into a null phase. In other words, minimal impacts. That's huge. All right, and then over here on the right, we have CFS V2, yes, working its way into phase 3, then kind of wrapping around, actually, ironically, over to phase 2 briefly, then coming back around over to phase 3 again, and then working in the weak phase 4 and then null phase by 20 February. So all these models are generally showing the same rotation of the MJO, the signal, well, with convection concentrated in the Indian Ocean. However, you will see some slight differences here. Number one, European is not as high amplitude, doesn't have a high amplitude like the Jeffs V12. That's an important thing to consider. And in addition, you do have, for the CFS V2, you do have it going briefly into phase 2 and then rotating back into phase 3, which is kind of strange. All right. What are the temperature composites when we look at months of February, March, and April with MJOs in phase 3 and 4? That's my focus, since that's generally the direction the models are taking the MJO. All right, so blue coloring indicating below normal temperatures, yellow coloring indicating above normal temperatures. So if we go to phase 3, it's not the kiss of death, okay? Now, stronger this gets in phase 3, that definitely could result in even milder temperatures in the east. But in general, if we get to a phase 3, it's not even factoring the magnitude, it's not a kiss of death for winter. Okay, you still have some colder than normal temps. And in fact, a lot of the models are showing colder temperatures, orientating themselves from west to east. And you'll see that here in a moment on the ensembles. And in phase 4, though, now if it gets to phase 4, let's say the Jeffs V12 here is correct and putting it in a stronger phase 4, we definitely could see mild temps over a large chunk of the United States come February. All right. So this is why I wanted to show you the differences between phase 3, colder temps, and MJO phase 4, a milder temperature regime. So this is why we care about what's going on in the tropics. What kind of tropical forcing are we seeing? How is this impacting the long wave pattern? Big things to think about. Right, now let's take a look at the teleconnections forecast. Now, tonight I broke down each of the individual teleconnections and I kind of show you what the pattern looks like on the right. So we're going to start with the European EPS 50 perturb members. So we're looking at the European Ensemble, and we're looking at the Eastern Pacific Oscillation, EPO. Look at the green line here. See how it dips far negative, all the way down to just around -4 of magnitude here by the 28th and 29th of January. That's the EPO, all right? And then it comes climbing up, and it doesn't get to neutral really until around the 3rd or 4th of February. All right, so this is interesting. The models weren't showing this a week ago, this strong of a negative EPO. And what happens when you get a negative East Pacific Oscillation, or EPO? All right, number one, you get a nice massive ridge developing in the Gulf of Alaska, okay? That ridge and those height rises generally tend to bend the jet stream. The front side of that ridge tends to result in more cross-polar flow. You get Arctic highs that start moving southeast towards the United States. And look at the pink coloring here, all right? So you get Arctic highs coming down. You get colder temperatures in the United States, generally focused from the Midwest to the Northern Plains. Your main jet stream then goes right across the southeastern U.S., right up to the Mid-Atlantic, in this case, with a negative EPO. All right, so this is why we look at it. The EPO does go neutral there around 4 February, as I mentioned. This negative EPO, this sharply negative, is going to favor that trough further east. I don't think that trough, if we're just solely looking at EPO, negative EPO to this magnitude here at the end of January, I don't really believe that that trough is going to be like way back to the west here. I think it's going to be more like what we're seeing here on the diagram. All right, now what about the Pacific North American teleconnections forecast? So, you look at this, you live in the eastern US, you go, okay, cool, cool, it's not going to be super mild. Now, we look at the negative Pacific North American pattern, the negative PNA here, the green line dipping down to -3 values there between 29 to 31 January, peaking out at its lowest point, and you don't like that, all right? Because look out here on the right, orange coloring indicating above average temperatures, and you just see what's going on here. I could just draw this out right here. I see this orange coloring from the deep south, southeastern U.S., the mid-Atlantic, Ohio Valley, up to New England. That is a warm signature above normal temperatures in the east with a negative PNA. See this? Coldest temperatures are back towards the Pacific Northwest and Western Canada. Okay. So I really don't like to see this kind of negative PNA, this much of a dip in it. The negative EPO, however, could be offsetting the impacts of this negative PNA a little bit. Now let's take a look at the Arctic Oscillation Teleconnections forecast. Green line here indicating the average ensemble, generally showing above the zero line in positive territory for the AO throughout this forecast period out to 7 February. Positive AO forecast. What does this favor? Why do we care about a positive AO? Well, the jet stream pretty much works high zonal, moves more high zonal west to east configuration, and we really don't get deep troughs in the U.S. And in order to get colder temperatures, you got to have the deep troughs. Without the deep troughs, without those highly amplified meridional patterns, you're not going to get the jet stream really to come further south, and that's going to result in a lot of rain in the east. So we are forecasted to see a positive AO. That would result in milder temperatures across the U.S., the coldest temperatures locked up over the Arctic. What about the North Atlantic oscillations, latest teleconnections forecast? Showing it fairly neutral right on through the 28th of January, but then it goes positive. Slightly positive, but positive nonetheless, right on through 7 February. Now, what does a positive NAO do for us? That is very similar to what the AO does for us. Positive AO, high zonal west to east jet stream, not a lot of dips in the jet stream, not a lot of cold air intrusions, Arctic air into the U.S. Coldest air remains locked up over the polar areas, right? So this is to me like some of the things that go through my head. So if I see a negative or a positive AO forecast, a positive NAO forecast, and if both of those indicate coldest air being locked up over the Arctic, right? But then we go back here to our friend, the polar vortex, okay? All right, and we see stratospheric warming occurring. We see decelerating winds. We see warming temperatures because of that strat warming, okay? Those impacts of a weakening zonal winds, rising temperatures in the stratosphere, we're getting a couple stratospheric warming events, okay? They're not major, but they're still doing work on the polar vortex to weaken it. A positive AO usually is an association with a stronger stratospheric polar vortex. So what's going on here? Why is this positive, the AO? Why is the NAO positive? Why is the coldest air locked up over the Arctic? Why would this be the case when something is working to offset it? And that'd be the polar vortex warming, strat warming here. Weakening polar vortex. It's easily displaced off the pole. Look where this thing is situated. The polar vortex is over the North Atlantic. So what I'm getting at here is the stratospheric polar vortex weakening, the stratospheric warming events, okay, the decelerating of the winds here, okay, that could act, I believe, to offset the impacts of positive AO and the positive NAO. And I'm just reasoning right now with you in this video. Okay, I didn't even think about this before making this video, or even while I was putting these slides together. I didn't even think about that, but now it's just dawned upon me. Sometimes you talk through things and you really start connecting dots. And, positive AO, positive NAO, okay, and then a weakening stratospheric polar vortex. They contradict each other is what I'm getting at. A weakening stratospheric polar vortex could result in additional elongation events or stretching events, which would not keep this Arctic air locked up over the pole. It would not result in a west-east jet stream. You get an elongation event of the stratospheric polar vortex like we're going to have here again at the end of this week, and that's going to result in a dip of that tropospheric jet stream, polar front jet stream, okay? So there's a good chance that there's a battle going on between, what these teleconnections are indicating, the AO, NAO, and maybe they're just not seeing the weakening vortex yet. All right, that's possible too, because you got to realize there's a little bit of a lag time when you get this stratospheric warming event. Sometimes the surface weather effects are not felt right away. Okay, so it's going to be interesting to watch the AO and NAO over time. Usually with a weakening polar vortex, this becomes negative, AO and NAO. So we're going to have to watch this really closely. Now let's take a look at some of the Ensemble model charts from today. I'm going to be showing you the GFS Ensemble on the left and the comparison of the European Ensemble on the right. So for this Thursday morning, the 26th of January, we see green coloring now entering the Ohio Valley as well as parts of the eastern U.S. We have this nice reflection of that cold, deep upper level low situated over the North Pole area. This is an association with that stratospheric polar vortex. You see it on this one as well on the right. But in general, we see that troughing that's now extending from the Midwest, working its way towards the East Coast. We have that nice subtropical ridge there, right? That southeast ridge everybody keeps talking about, situated over the southwestern Atlantic. And then we have a nice little two major features here that are really interesting to me is this stronger upper level height center and anomalously high heights across the northeastern Pacific again. And then we see another one here in the North Atlantic on both Ensemble models, okay? You got a very strong upper level ridging in the North Atlantic in both models. Now, let's look ahead to Saturday, this Saturday, the 28th of January. And we still have a nice reflection of that deep closed low over Hudson Bay now. Along with these upper level ridging features again. This is kind of starting to look a little bit like December again, in early December, when we have massive upper level highs, a massive upper level ridging occurring. Now, this is to the east of Greenland here. So this would be more of an east-based negative NAO. But this is really interesting stuff. I mean, look at the ridging now extending well north of Alaska by this Saturday morning, and both models are showing this. Okay, so we got high latitude blocking occurring on both the North Atlantic side as well as the Northeast Pacific side, and then we have this deep, deep closed low in the vicinity of Hudson Bay, Canada, association with the polar vortex. And then we still have the subtropical ridge situated just to the southeast of Florida, generally over Haiti and Cuba and that location, Puerto Rico. Let's move ahead to Monday, the forecast for Monday, 30 January on the Ensemble upper air charts. And now look at this. Look at the stretching now of the vortex here. This is 30 January. The lowest heights are stretching back to the southwest in both models, both the GFS Ensemble on the left and the European Ensemble on the right. See the stretching? And then we still have this massive upper level ridge and blocking occurring right up into Alaska. Now, you will notice that some of these higher heights have actually decreased a little bit. And they're not as high as they were, let's say, on this upcoming Saturday. See this in the upper right? So we still see upper level heights, generally high across the North Atlantic. We still have a very strong upper level ridge into Alaska on both models. And we have that major deep upper closed low over Hudson Bay. By Wednesday, the 1st of February, we now have that ridging extending further to the northeast from Alaska, working its way towards the Arctic Circle. We have deep troughing downstream of that ridge. pretty much northerly flow through western and central Canada, and then it rotates around the base of this shortwave trough on into eastern Canada. We do see a little bit of a ridging signature now showing up. The European ensemble a little bit stronger with that ridging feature, and height rises along the eastern seaboard. Right, by next Wednesday, the 1st of February, as we kick off the month. We look at Friday, the 3rd of February. I believe this is my last one yet. All right. Generally, what the ensemble models are showing today, the GFS on the left, GFS ensemble on the left, and the European on the right, those higher heights are now diminishing a little bit, right, over Alaska on both models. We do see a little bit of troughing now that's developed off the Pacific Northwest coast as well. We also notice that ridge is really weakened across the mid-Atlantic up to New England. And actually, that ridging over New England on the 1st of February has been replaced by lower than normal heights and troughing. We see massively cold air across eastern Canada. What I really like about these model runs today, if you want a little bit of winter weather in the east, is I like the fact that we now have a cold upper level low over Hudson Bay. And it goes all the way out in time. You got cold upper level low in the vicinity of Hudson Bay in eastern Canada. You got northwesterly flow, generally developing the upper levels of the atmosphere, attracting colder air down into the United States. I like that look. It's a nice look. So we'll have to keep an eye on that. Now, in addition to what could potentially happen with the MJO and the stratospheric polar vortex, it's going to be a very active weather pattern. Now, I know I'm going to show you operational model charts, and I know they're going to go way out to 7 February, and I know this is going to change, but I just wanted to show you the trends in these models, okay? One of my key points I made in the last video is, where does the baroclinic zone set up? Does it set up further southeast off the southeast coast? Does it set up right over the mid-Atlantic in the southeast? Does it stay back further to the northwest? Okay, there's a lot of variables here at play. Number one is the MJO phase and magnitude. Number two is that stratospheric polar vortex. Strength of it, where does the coldest air after the stratospheric warming occur? And so right now, this is for 30 January. We're showing an area of low pressure in the forecast off of Cape Hatteras, and an area of rain up off the mid-Atlantic. That's storm 1 on 30 January. Here's storm 2 on the right, showing another area of low pressure in the very similar position off Cape Hatteras, and another round of rain up the eastern seaboard. And now we have a little bit of snow on the northern edge and the cold air in parts of PA, New York State, and in parts of New England, Massachusetts, Connecticut, and so on. Bottom line here, these blue dashed lines indicate very cold air. These red dashed lines indicate milder air. And the baroclinic zone is going to be the boundary between the very cold Arctic air to the northwest and the milder air over that Gulf Stream, the Gulf Stream ocean current over the western Atlantic. And that baroclinic zone is going to set up, and these storms are going to form and ride along that zone due to the great thermal contrast or temperature contrast on either side of that baroclinic zone. And right now, it's looking quite wet, no matter what type of precip we're talking. It's going to be a wet period, an active period, it looks like, as we head from late January to early February across the eastern seaboard and mid-Atlantic. Again, the major question is, do we get one of these strong Arctic air pushes to extend a little bit further to the south? Does the trough dig a little deeper? Do we get a strong 1040 millibar plus high over the northern plains to really, really push the cold air south? And then we also got to watch out for the possibility for cold air damming. If we get a strong 1040 or even 1035 plus millibar high over the Great Lakes, that clockwise flow around the high is going to drive some very cold air from upstream from Canada, eastern Canada, right down the east coast. And that cold air damming, that colder air is very hard to erode, especially this time of year when you don't have the strongest sun angle, the highest sun angles, the strongest solar radiation to erode it. And so there's going to be a lot of times, I believe, over the next 10 days or so with this active pattern where we easily could see wintry precip to start changing to rain. Or if the baroclinic zone is further back to the southeast, it could be a situation where we see more wintry weather further southeast. Or if the baroclinic zone sets up to the northwest, you're going to have mainly rain events on the east coast. So there's a lot of potential here. Here's the 4th of February forecast on the left. Again, another storm system. Another one. And on the right here, showing you where that baroclinic zone is. Look at where the moisture is, the axis right there. And by this point in time, the GFS model is showing a little bit of a stronger ridging westward of that subtropical ridge. So bottom line is, we're counting 4 particular storms generally along this baroclinic zone off the mid-Atlantic coast between 30 January and 7 February. It could be a very active period. This is the Climate Prediction Center. This is the 8 to 14-day precipitation outlook just to basically to verify what I was just telling you. Again, I know these are operational models and they're going to change every 6 hours. So please don't take me verbatim for where these lows are stamped. But in general, I look at the patterns. What's driving the pattern here? It's this major temperature contrast between Arctic air. A couple days ago, it was looking very, very glum as far as potential for any type of winter weather in the eastern U.S. And the models keep coming back to this solution where you get colder periods of air oozing south, these colder pieces of chunks of cold air just oozing south. And all it would take is, a little bit further to the southeast movement of this colder air and the timing of these storms to potentially give you a surprise mid-Atlantic winter storm. So it's going to be interesting. Timing is everything. I kind of mentioned that in my last video. All right, so now my final thoughts on tonight's video. We are going to see a major battle zone setting up from the Ohio Valley, somewhere between the Ohio Valley to the East Coast, with multiple storms in late January and early February time period, okay? That major battle zone is that corridor, that baroclinic zone where we have strongest temperature contrasts. This is where you're going to get your wave cyclone development, your storms that develop along the zone and move up the coast. So make no mistake about it, it looks active. Do we get more inside cutter type storms where they're way back here over the Ohio Valley? It's possible. And if we keep the storm track way back here to the Ohio Valley, it's going to be rain, and more rain across the mid-Atlantic to New England. The major influences of the upcoming temperature regime, they include the Madden Julian oscillation, as I talked about. It's moving toward, it's in phase 3 now. The Jeffs model is showing a much stronger amplitude or magnitude of the MJO phase 3, working its way to phase 4, whereas the European model is showing a Madden Julian oscillation weaker in phase 3 and then back to null phase. That's huge, okay? Because my main question is does the MJO move into phase 3 and 4 with stronger magnitude, according to the Jeffs model, or move into those weaker phase 3 than the null phase, according to the European model? Now, if the Jeffs model is correct, phase 3 highly amplified, and then phase 4, then we're going to see stronger upper level ridging and milder temps across the mid-Atlantic in late January and early February. But if the MJO follows what the European model is forecasting, we're going to go into phase 3, but the amplitude's not as great, and then the MJO rotates back into the null phase where we will have minimal impacts from tropical forcing. This is huge. So we'll have to keep an eye on that. The ensemble models and the operational models are not in agreement with each other in the 7 to 14-day time range. So there's still lots of uncertainty remaining. All right, and let me show you an example of this. Okay, so this is 30 January. What was my Jeffs model run here? Okay, yeah, I got a Jeffs model run here on the left. This is for 30 January. Okay, look at where the ridging is, orange coloring, all the way from Florida right up to New England, up the East Coast. See the orange coloring? These are higher heights. All right, this is 30 January. Okay, so what would that mean? If I just look at this, I would expect that my storm track would be up over the Ohio Valley. I would expect it to be back here. But what's really happening on the forecast model operational for 30 January? Why is the storm way out here? It's off the coast. All right, so it's interesting that it's not back here. So right now, there's just not a good agreement between the operational models and the ensembles. Additionally, the operational models are showing a lot of cold air on the playing field upstream of the mid-Atlantic. There's a lot of cold air on this playing field. Okay? Reminds me of football. We're in the football playoff time of year. And whenever you have cold air on the playing field, or in the case of a football team, anytime you have players out there playing and they're giving it their full effort, there's always a chance that underdog team could always win in football. They got their players out there, they're playing hard. The same thing goes to the atmosphere here. You have lots of cold air upstream of the mid-Atlantic. Whether you go to the north towards eastern Canada, whether you look to the northwest over the northern plains, there's going to be a lot of cold air up there, upstream of where we're at. Okay. So whenever I see a lot of cold air on the weather charts, and we're in late January, um, I'm not giving up on winter yet. Is what I'm getting at here. The stratospheric polar vortex is forecast to weaken. All the models are showing this. It's going to undergo multiple rounds of minor stratospheric warming, not major, but minor. But again, that minor stratospheric warming can still have an impact on our weather pattern, our tropospheric jet stream, the placement of the air masses, the colder air masses specifically into the U.S. And also, this could offset the effects of that warmer phase MJO pattern. If it goes to phase 4, what will the stratospheric warming, event and that ultimate weakening of the polar vortex, what are we looking at here? The latest models today I was looking at, we're showing another round of elongation possible in the eastern North America in early February. And that would favor colder temperatures in eastern North America, not warmer temperatures. So we have a lot of battle going on here. We see strongly negative EPO along with a strongly negative PNA forecast in late January. That's another battle that's taken place. And then you got the NAO, AO and NAO positive. And I kind of already talked about that. There's lots of teleconnection destructive interference that's ongoing. And I do expect that to continue. And then, I think that's the last slide, yeah. The location of the baroclinic zone, that battleground, is going to be critical. Where it sets up, as far as the precipitation and air mass type over specific areas over the next 2 weeks. So there's a lot going on today's weather charts. There's a ton of activity as far as storms go. I'm not one to give up on winter, but when I see the stratospheric polar vortex situation becoming weaker, and when I look at, we look at the, where was I at here? I look at these stretching events of the southern of the polar vortex and the stratosphere, and then ultimately what I look at, I meant to go this way. I see a lot of this, these blue dashed lines, these lower thickness values upstream. Okay. And occasionally you see this, the ridge kind of weakens offshore, and it opens a door and allows these stronger troughs to move further southeast. And I like the look of the upper level low over eastern Canada, Hudson Bay and eastern Canada. I like that because you're going to direct colder air from these source regions up here in eastern Canada. It's going to work its way south into the United States ultimately over the next 10 days. So I'm not giving up. We're going to see what happens and we'll see where it goes. And then I'm just going to end it with tonight's title, everybody. Okay. Good things come to those who wait. All right. That's all I've got for now, everybody. Until next time, take care and God bless everyone.